Hello everyone, my name is Jabeena from JNTUA College of Engineering Kalikiri. Today I am presenting my internship project titled Microcontroller-Based Washing Machine Simulation on PICSimLab, developed under the Embedded Systems Internship B8 at Emertxe, mentored by Miss S. Guhapriya. The goal of the project was to simulate a real-world washing machine using PICSimLab. This involved replicating operational cycles and various settings, and it involves to implement all core functionalities including power on, program selection, water level adjustment, start pass control, and safety alerts like door status. Here is a brief overview of the presentation structure. I'll be starting with the introduction to the embedded systems. Next, introduction to C, microprocessor versus microcontroller, memory, requirements, peripherals, output, tools, conclusion. Let's start. Introduction to embedded systems. Embedded systems combines hardware and software to perform a real-time operations. Embedded systems are the computer systems which does a specific task, and these were used in the industrial machines and IoT devices, etc. The key features were low power consumption, compact size, and real time performance. Here are the categories of the embedded systems. There are five types of the categories, starting with the standalone embedded systems, which work independently. Those were two types. Slave standalone embedded system follows user instructions strictly. Those doesn't take actions on their own. Independent standalone embedded systems takes decisions on its own. Next one is the network embedded systems. Multiple components connected together forms a network, right? So that's how a network embedded systems is called. Real-time embedded systems. In real-time embedded systems, deadlines are strictly followed. There were three types: hard real-time, firm real-time, soft real-time. In hard real-time systems, if the deadline is missed, there would be a human loss. That is a huge loss. In firm real-time embedded systems, if the deadline is missed, then there would be property loss. In soft real-time systems, uh, delay can be accepted, like uh, like our washing machine project currently. Uh, the next one is the mobile embedded systems, which were movable embedded systems. Hybrid embedded systems means the embedded systems which fall into more than two categories, like our washing machine, which falls in standalone and soft real time because we are running it on the PICSimLab. Uh, Next is the introduction to C. As we all know, C is the primary language used in embedded development. It allows us direct hardware access, supports efficient register manipulation, and gives precise timing control. Supports bit manipulations and offers direct control over the hardware. And the main advantages of C is hardware friendly, portability, speed and efficiency, and structured programming and rich library support. Let's go to the next slide. These were the contents which were covered in C. These are the concepts that I have used in the project: data types, storage classes, looping statements, operators, arrays, pointers, functions, strings, preprocessors. Let's start with the data types. The data types are used to allocate the appropriate memory and define how the data is being processed. These were the mostly used data types: int, float, char, double. Char takes only 1 byte of the memory, so mostly used in to reduce the memory. And the syntax for the data type is data type variable name ended with a semicolon. Uh, for example, unsigned char var ended with a semicolon. This is the example. Next, go to the storage classes. The storage classes are of four types: auto, extern, static, register. Um, as we see this left side of our screen, this is the memory layout of C language. These were the segments, starting with the text segment where the actual code is stored. Next is the initialized data segment where the initialized variables are stored. Like if you initialize a variable with that data with a value, like int a equals to 5, it is going to be stored in the initialized data segment. And the next one is the uninitialized data segment, which is BSS. These global variables are stored in this. Like if you initialize uh, int a in semicolon, it is going to be stored in the uninitialized data segment. Next one is the heap segment, and then next one is the stack segment. The R2 class is under the stack. If you like if you give a variable with the auto class, it is going it gets the garbage value initially, and the scope is within the block, and the life is end of the block. Extend 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 is a extend is the keyword which is used to access the variables from the other files also. It is stored in the data segment, and it is initially the value is 0, and the scope is globally multiple files, and the life is till the end of the program. Static static is stored in the data segment. Static uh, is to retain its values between the function calls. It is initially having the value is 0, and the scope is within the block until the end of the program its life. Next one is the register takes the garbage value initially, and the scope is within the block, and the life is end of the block. Let's go to the next slide. Operators. Operators are of four types, mainly: arithmetic operator, relational operators, logical operators, bitwise operators. Arithmetic operators are used for the mathematical operations like addition, subtraction, multiplication, and division. And the relational operators are used to compare the values, like whether the value is greater than or equal or less than or equal, etc. And logical operators are used for the decision making, like we can give the condition um, like turn on the LED if the switch 1 and the switch 1 is pressed, and the initially the LED is having the value of 0, like that. And the bitwise operators are used for the register manipulation. Next one is the looping statements and conditional constructs. uh, there are three looping statements: for, while, do while. For, uh, for we use for if you know the iteration count. For example, flash LED 5 times. Here we know that uh, we know the count, like 5 times we need to turn on the LED. While is used when you don't know the count, and it will continues as long as the condition is true. Do while. Do while executes at least once. And let's come to the conditional constructs. Continue and the break. Continue is a keyword. Like if you use the continue, the code after the continue is skipped. Break means break is mostly used in the switch cases. Exits the loop, like exits that particular case. Let's go to the next slide. Arrays. Arrays are the collection of homogeneous elements. Like it is the collection of characters which is of the same data type. The syntax is data type array name of size ended with a semicolon. Uh, Here arrays are used to store the strings, like strings of the messages. Next one is the strings. Strings is the array of characters used for displaying the messages, like here in the washing machine. If the used for displaying the water levels and the washing program. And the syntax for the strings is data type array name of size equals to, in the curly braces we can give the messages. Okay. Next one is the pointers. Pointers are used to store the memory address, which allows the direct register access and dynamic memory reference. The syntax is data type asterisk pointer name ended with a semicolon. Let's go to the next slide. Functions. Functions which functions are used to reduce the code, like a block of statements together perform a task that is known to be a function. Function is called many times, like we can reduce the code, the block of statements we can write it in a function and then we just call that function to perform the task. The examples were void fun, int main, and the preprocessors are used to tell the compiler, like compiler knows that compiler first first will process that particular things which we defining, like these were the two types, like hash define new name value, like simplifies the naming, like we can assign a variable, we can assign a data to the variable through this, like instead of calling that number, like we can define hash define on 1, like we can call on instead of one, writing instead of continuously one. Next one is the hash include. Hash include means it simply adds the library functionality. Okay, let's go to the next slide. Microprocessor versus microcontroller. As we see, microcontroller is of inbuilt. It will be having RAM, ROM, timers, interrupt control, and the input output ports and the serial port. Uh, as as well as the microprocessor. Microprocessor is having just the ALU control unit and the register arrays. The devices has to be externally connected, so that's why microcontroller is mostly used, which is known to be system on the chip. Memory is simply means stores the data. There are two types of memory: volatile, non-volatile. Volatile is temporary memory. Uh, Temporary memory, like storing the ongoing things. They were SRAM and DRAM. SRAM is the fastest and retains data well powered. DRAM is the slowest and we can store more data in the DRAM. Needs constant refreshing. And the second one is the non-volatile, which is the permanent memory. The access is more that time for accessing the data takes more time. Uh, and these were five types: MROM, which is the masked read-only memory, which is the pre-programmed during manufacturing. Next one is the programmable read-only memory, which is the one-time programmable. EEPROM. EEPROM is the erasable, like you can erase the data using the UV light and reprogram it. Next one is the EEPROM, which is the electrically erasable and the reprogrammable. Next one is the flash. Flash memory is high speed, like block based, electrically erasable memory. Let's go to the next slide. These were the requirements. Here I'm Here we are going to use a microcontroller. Switch 1 is used to read the door status. Switch 4 is used for the navigation. If we short press the switch 4, we can scroll the options. If you long press the switch 4, you are going to select that particular option. If you press the switch 6, it is used for the pause. It will be pause or stopped. Switch 5 is used to power on the system, power on the washing machine, and character LCD is used to display the messages, and buzzer is used to indicate the operation has been completed. The motor is used for the washing purpose. Let's go to the next slide. These were the peripherals used. Microcontroller. Here I'm using PIC 16F877A for the washing machine simulation, which is a 8-bit microcontroller from the microchip company. The key features are it consists of 40 pins and 5 input output ports: port A, port B, port C, port D, and port E. It will be having 8 kilobytes of flash memory, 368 bytes of RAM, 256 bytes EEPROM, built-in ADC, timers, PWM, USRT interrupts are built-in. So operates at up to 20 megahertz. Easy to program and simulate using MPLab and PICSimLab. This is the architecture which I have told you. These were the ports and timers, all are inbuilt. Next, this is the fundamental peripheral like LED. LED which is used to indicate the power status or the output activity. It emits light when forward biased with current. It is controlled with the microcontroller pin. Uh, if it is high, means the pin is at high, then the LED is going to be turned on, or else it will be off. Switch is used for user input. Uh, this is implemented using the pull up and pull down. Pull up means initially the pin is at high. If you press the button, it is going to be low. The pull down means the initially the pin is at ground, which is low. If you press the switch, it is going to be high. Next peripheral is the digital keypad, which is used for user input. And as we know, this is the matrix of buttons, and this requires a scanning algorithm to detect the key press, whether the user is pressed the key or not. Needs the debouncing, and common in security control panels and calculators. Next peripheral is the character LCD, which is the alphanumeric display. Here in my project, I am going to use 16 into 4 LCD used for showing the messages, values, and system info. Next one is the buzzer like which is the audio indicator. It is controlled with the microcontroller pin, and after the completion of our program, it is going to alert the user that the program is being completed. Warnings and or completion. Next one is the fan which ensures the thermal safety of the electronic components. So requires external power source and driver circuit. Next one is the interrupts. As we know, interrupts is a disturbance. The CPU is running a program. If the interrupt occurs, it goes to that interrupt service routine. It 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 will it will make that service and return back to the main program. Um, Improves the real-time performance of the systems. Next one is the timer. Timer is used for the time delays, periodic tasks, and PWM generation. As we know, in my PIC microcontroller, there are three different timers: timer 1, timer 0, timer 2. I'm going to use the timer 2 for my project, and this is the essential for real-time control and event scheduling. Next one is these were the output screens. Step 1, power on and program selection. If you press the key 5, it is going to power on the washing machine and it will show the washing program. You need to select the washing program. These were the 12 different washing programs that I have used in the program. And if you want to select that particular option, you need to long press RB4, uh, switch RB4, switch 4, which is the RB3. Next one is the setting water level and starting the operation. These were the 5 different water levels I have used, and if you want to start, you need to press the switch 5. If you need to stop, you need to press the switch 6. If you press the switch 6, it is going to display the washing program again. So these were the execution. And safety and completion is if the interrupt occurs, door is open, please close the door. The message is going to be displayed, and after completing the program, it is going to display that program completed and remove that clothes. These were the tools that I have used for the implementation: MPLab IDE, X8 compiler, PICSimLab. Let's let's implement it. I'm going to the MPLab. This is the code that I have written. Okay. I'm going to build this. These were the different source files that I have used to write the code. Means it contains the code for the character LCD, and digital keypad is for the digital keypad. ISR means the service routine. In the main.c I'm going to like give these functions, and in the project definitions I'm going to use some user defined functions like for turning on the display. I'm going to use power on and clear screen functions, and these washing program screens for that one. Next one, these were the header files that I have used. So build is successful. Now let's see. Here the board is PICGenius, and the microcontroller is the PIC16F877A, and here I'm going to use the frequency of 20 megahertz, and let's load this file. Here I'm using the 16 into 4, right? So I'm selecting that one. Let's load the hex file. This is the hex file that I have built. So here it is showing press key 5 to power on the washing machine. I'm going to press. Now it is power turning on. So these were the washing programs. For scrolling, I'm pressing the switch 4. For selecting stain wash, I need to long press it. So for selecting it shows the water level screen, right? So I'm going to select low. For scrolling down, short pressing the RB3, which is the switch 4. Now let's see. I'm selecting low. Here it is switch 5 to start, switch 6 to stop. I'm going to select the switch 6, which is the RB5. The program is lengthy, note is taking some time. So now if you press the stops, means it will again shows the washing program. Now let me select this stain wash. I'm long pressing the switch 4. Now I'm selecting the medium. Now I'm pressing the start, which is the switch 5. Here you can see the stain wash is selected and the time for it is 41 seconds. So now it is going to be washed. The function is wash. Now if I press switch 6, it is going to be pause. Now I'm pressing switch 5 to again continue. So RB0 is the interrupt. I'm going to press. You can see if I press this interrupt, like which is the RB0 is used for the door, right? The door is open. Please close the door. Is showing. So this is washing now. After some time it is going to rinse and then it is going to spin. So this here we can see the fan is rotating. You can see rinse now. Now you can see it is spinning. Now you can see after the completion of the program is completed and now remove the cloth. As you can see, the fan is also stopped. Likewise, we need to select. It comes again the washing program. Like we need to select the again. So this is the demo of my project. Let's go to the slides again. Let me give you the. So these were the files I have shown. Main.c, clcd.c. In that clcd function is .c file, I have used the init, putchar, print, write functions. In the digital keypad, I have used the read digital keypad function and the init function. In the project definitions, power on screen, clear screen, washing program, display, water level screen, run program, set time, door status check. These were the functions that I have defined in the project definition def.c. So this is, let me conclude. uh, I successfully simulated a real world washing machine using the PIC16F877A microcontroller. I gained the knowledge on this and the valuable hands-on experience in embedded C microcontroller and project structuring. um, this project improved my skills, and this project has strengthened my foundation for future embedded systems and real-time automation projects. Thank you for listening.